remember and check, so on. So I'm afraid you are confusing with the numbers given. Okay. Okay. So before we start, we recap back why we use cryptography. And why and how cryptography can be applied in cryptography. How chaos theory can be applied in cryptography. Okay, it is because the sensitivity of initial condition, and then we can have the pseudo randomness for our generation of the key, and also because it is non-linear dynamics. Okay. And for this tutorial, I will go for the key generation, for encryption algorithm, and also hash function. I didn't manage to complete for the stream cipher, a simple example. Yeah. But then we will go these three: key generation and how we secure the data for the encryption algorithm, and also hash function. Okay, so let's go for the first one, key generation. So maybe I would like you to try, because it's just a short, short code, how you can use to generate a key using logistic map. So this, we are using the logistic map. So basically for the first few row, we have done previously using Lorentz, so it will be actually the same. And for logistic map, we have the initial condition and also the parameter. And then we iterate the chaotic sequence for the key. And this is my example. I iterate for 10 keys. For, let's say in that particular case, I just want to use 10 keys. So this is up to key, how many keys that you want. Okay, this is just for generating the key. Okay, so you want the key that to be used for the algorithm. Okay, so and then you input your logistic map. So this is what you input your logistic map. So logistic map is actually R into x minus 1 times this one. No, it's actually because this one we are using SI, so this one will be x minus before it. So previously in my lecture, Rs plus 1 equal to Rx into 1 minus Sn. Okay? So you use this chaotic sequence to generate your key, and then So, you got the answer? Where is the display key? Okay, so basically the answer is 128, 64, 135, 153, 162, 176, 42, 12, 18, 83 to 110 and 46, right? So this is because the iteration they are giving you the answer of 10 because you asking for 10 key. Okay, so try to change your initial condition, and what will happen when you change your initial condition? Let's say into 2. Do you got the answer? So maybe I will just check because it's difficult for me to. So I just share slide by slide. I mean side by side. The MATLAB plot and also the slide. So you can see clearly. Okay, so if you can see there is the generated key is not that good. Can you tell me why this is happening? Why when we input initial condition as 2, why this is happening? Anyone? So it actually applies to the behavior of the system. In this particular point, the stability, I mean the chaos behavior is not there. So that's why in logistic map we cannot use 2 because it doesn't produce what we call chaos. So if you change it 0. Just now is 0. The previous 0.4. So let's say if you produce it less than 0.4, so it can produce means that the initial condition for logistic map I think between 0 to 1. That is perfect for chaos behavior. So there is also that you need to have the knowledge before you go for cryptography. Okay, so that is the example for logistic map. So everyone then you can choose if you want to use maybe in that purpose for maybe you can think, oh, I want like to use X, so you change to Y, so you just use Y for the key generation. Okay, so then this is good. Then you just change your key state X. Okay, so if you want to do what I can do. No, no, this is like yes, yes. So you but then this in what purpose? I mean, but then yeah, you can choose. This is this is for solution of X, solution for Y. Okay. Okay. So you got it for the key generation. So this is actually very simple for us to just generate the key. Okay. In any purpose that you want to do for your, for your algorithm. So let's move to the second one. Okay, so we try to transmit the plain text. My data will be a text message using SOR method. So maybe I can make it larger here. So I'm can you try? And then try to run. What would be your ciphertext? I mean, what is the generated ciphertext letter? So this one I'm using the time map. So this is the, you can check from the previous lecture the equation of the time map, because there is a piecewise function where x less than 0.5 and x greater than 0.5. So that's why this is we need to look. Okay, and then the other difference, just now, because just now we just generate the key, so there will be no encryption algorithm. So in this case, because we want to encrypt our text, so we need to have the algorithm. So in this particular 17 is the algorithm that which we are using SAW method, and then we need to also have the decryption method to see. I mean, it's just a method to see it is revisable. Okay. So whenever you put plain text, you need to check whether your decrypted text will be the same. So then, meaning that your algorithm will be in the proper way. Can give me 5 minutes? I go to the toilet. Okay, can you try with this and play around with your plain text to see your ciphertext? Okay? this one, if you done, you can play around with another kinetic system, and then you can try to, what we call, to adjust the code to make it suitable with that kind of system. So if I want to encrypt your name, the decrypted is, what is the number for your name? This one, this is just the key, so this is the certificate. So this one will be all over the internet. 91 out of 01. So that plaintext, you actually can change to any the word that you want to. It can be that. It can be long also. Okay, it's not necessary to be one word, so it can be long. Okay, and then you can see the result. For example, like okay, this is what my current state is. Okay, so the ciphertext will be command window because it's a checking process. So anything that you want any input that you put in that algorithm, so we can just directly enter your plain text. And then the second thing is we convert the plain text into ASCII, and then we generate our chaotic 10 map, and then algorithm that we need to include in our model. So sometimes in this particular case we need a simple one, but then in some particular things we need the difficult one. So that's why we start from the small one, the simple one, then you can proceed and you can learn how to design algorithm. Okay, so that is the sort and substitution. So I include the same one. So maybe after this you can try by yourself, or maybe also use the 10 map to see use the 10 map for the substitution method. Okay, you just change this line. Okay, and then the next one is image between these two image, and I plot the result. So you can skip this part. Maybe you want to try for the image, then we can, yeah, I think better because okay, you can feel it. So try. I cannot fill for full code, but then I will go up after you done. So try for the image, and take your own. Your image, any image that you have in your desktop. Okay. Try. Good done. So Shika is so fast. Where is the image? Shika is so fast. What is the result? What is your picture? Oh, maybe you didn't put it, right? You didn't input in your result. You have to plot. Oh, but then you are so fast. I need to go down. Because we want to see the figure, right? So we want to see the figure, your original. What is your original image that you input? And then the indicted image will be very noise. And then the detected will be the same, suppose. Okay? So try to plot your result. Okay, I will go up first, waiting for the others. Okay. Or maybe you can take pictures for the first, and then I can go for the next, right? Okay, so take pictures for the first, and then I will go for the next. So then you can have both, and then you can type in your computer. Done? So I go for the next, yeah? So I think I need this one. Oh, I print the error analysis already. Oh, it's not coming full, right? Okay, let me make it this bigger. image represent our wave. So that's why this plot is needed. This plot will be very needed. I mean, when we write a paper and everything, so we need to show the pictures. So that's why we need to come up with the plot. So this is the plot. Okay. If not, we cannot justify that we are successful with our algorithm, because we are talking about what we call image. Same like audio. Audio, we need to show the frequency of the audio, so then it can prove. I mean, audio we cannot hear. I mean, the paper we cannot listen. So we show our plotting the frequency of the audio signal. So then we need to plot our audio. So have you done with the image? I want to see your image. go for hash function, maybe I just want to show you my audio. Okay. Wait, let me check my audio. Okay, so this is for audio actually. I'm using the time map and I take any initial random, initial condition, and then I put the audio, and there are few justification that I need to use to make sure it can fit with the chaotic system and also the SAW encryption, and then mm, and then we need to make sure the dimension match. So that is good if you can have a longer dimension to make sure all the any audio that you input can be run. Okay, and we are using SAW method, which is we take the audio with the key string and do the revision process, and we save our audio. So maybe here we can hear. In MATLAB I need to find the WAV format. So wait. XOR method, and you will get the original back after the decryption process. So basically, if you put if you you should try this one also. For this example, you can have the same one, but then when it comes to the error for sure about the dimension, so you need to correct your dimension only. So you should try to have any example of the audio for the process. Okay, so I can share this. I have Chika's number already, so maybe I can share you the code. So easy for you to go and try and do the revision for your purpose of encryption. Okay. And then last but not least, we go for hash function. So hash is actually very important. We've got so many things that we use for hash. So that's why I want you to use. I want you to use chaos in hash function. So basically, this is the the the, the code. So let me. Oh yeah, I have it. And hash is also not that much, not that long. So maybe you can try for hash code to see the result. So in my case, input hello, and then so in hash also doesn't take long time for you to have. And this one I'm using the logistic map. Okay. So try. Even you are putting big hash or small hash is all matters for hash. So maybe you can try for hash. So it's actually we have the sequence and for the iteration, and then we put our sequence hash sequence as our from our result, our chaotic result. So and then You got the value of hash? So in my case, I'm using hello. My hash would be this value. So whenever I change even a small, we can see if I change the small hash into the big hash, it will be very vast different value for hash. So it will be, I mean, hash will not repeat the same value. It will be coming at different value. You can see. So let us compare. So for the first hash, small hash, we get like 1,000. I mean 1,300,000 something. But then this one is 1,200,000 something. So and for hash will be 2 to the power of 256. So that is the exact integer for hash that will be used. So it's the fixed one. Okay. So I think that's all after hash. Yeah. Any question? Anything that you need for the code, I will share with Shika. Okay? So you just let Shika know, then Shika will tell me.
Where we use normalized for creating
hash. Because okay, we need to use the normalized value to 1, right? For hash value. So because now it is reversible, we want it to be adapt, not adapt. We want our RC value to be follow the kinetic sequence. So that's why we normalize to 0 to 1.
In the code you have not generated hash sequence, right? You generated hash sequence. But how do you use this? How do you use hash sequence to generate that hash sequence?
Okay?
How do you use this hash sequence to generate the hash value?
Yeah, this one. So yeah, let's go through one by one. Okay, so okay, now for the equation, okay. So now we need to combine and normalize the message. This normalized message is up to for the hash value. Okay, so we use the mode 1 here. I think this one's still long. Yeah, so to the mode 1. For us to combine the sequence, because when you use this combination kinetic sequence, we will have in decimal number. So we normalize to mode 1, and then this is the formula for us to generate the hash value. So we take the combination of the combined sequence, and then we normalize it to power 6. And then we reduce the value to the power of 256, because hash must follow these integers. So this is the way we generate the hash value. Okay? So maybe just now you just looking at the top, you didn't notice this one. Yeah. But then my mode, it doesn't appear in this one. But it's okay, I will share with Shika if you need. You just let me know. Tomorrow, okay, we'll share everything. Tonight maybe after then we sleep. So, any question? Okay, so we recap. We already done with the text, image, also audio. But then audio I just touch a bit because I know if you put any audio that you have, it will be errors because of the dimension. So you need to make up with the errors. So that's why I don't want you to do that audio. So text, image, and audio, and then we already use encryption algorithm in the encryption method, which is SOR and substitution. Basically, I'm using most of the in this tutorial is the SOR method because it's easy, it's reversible. So and then we got the result, and then we already use logistic map, right? We have used logistic map, right? Just now for the first one, okay, and then 10 map, right? And Hanon map. Hanon map, I actually give you the exercise, but then yeah, we have. So you can try with Hanon map, and then what else? The chaotic system that we have done. That's all right for today. Okay. So maybe I asked Shika to run with the Lawrence. You got perfectly. So you can try with any chaotic sequence in this particular code, then it will be success. Maybe there is some few line that you need to add for the dimension and everything. Okay. So any other question? Okay, I'm giving you the code by Shika, and Shika will tell me which one you want, then I will just set them. Okay, I will give you. Okay. Yes.
Can you go in the code for Hanon?
Hanon map. Need to remember which one.
Sub-Hanon. This one.
Not this one.
The file name Sub-Hanon.
Yeah.
It's open only.
Oh, this one. Okay. Yeah.
So in this decrypted one, you are using ciphertext minus keystring plus 256, right? So we don't, it's like
Yes.
we don't need to use plus 256, right?
This one.
Yeah.
Basically, it's actually the same. It's actually the same, but then sometimes the things that happen to me, sometimes it doesn't appear the result. So basically, in theory, this is the formula. So ciphertext minus keystring plus 256. So this is in theory. So that's why I follow the theory. Because there is time that I didn't get the result. Thank you for noticing that. That is good.
This hash function generates the same length of the like same length hash value.
No.
For different texts, like for different length text, does
No.
it generate the same
It
length?
depends because we have this